Hello, thank you everyone for having me, giving me the opportunity to talk to you today about Apache Karaf and microservices. Before I dive into the presentation, I would like to just quickly ask from the audience, how many people here develop microservices? A couple people. Any Java developers in the room? A handful, that's good, okay. So what I'm going to do during this talk is I'm going to talk about microservices as an architectural decision and how we're able to make it easier to develop with microservices, to deploy them, use them in your regular application development cycle. And then I'm going to talk a bit about how Apache Karaf helps you get this goal completed. In the presentation, I'm going to go very quickly through just what is a microservice, what does Apache Karaf provide you with, go over a couple of user stories that we've seen that's kind of very illustrative of how it's being used in the wild, and you can go offline and take a look for those for more information. And then I'm going to go into a live code demo so you can see this whole platform working the way that we like to build microservice applications from the Karaf point of view. So a little bit about myself. I come from Newfoundland. I'm an Apache open source developer. All that really means is that I do a lot of software contributions to the Apache Software Foundation on a couple of particular projects, such as Karaf, Felix, and Service Mix. All of these projects are to do with microservices and being able to provide them as a service to users and allow developers to build microservice architectures. Just for the full disclosure, I do this as well as part of my day job. I work for a company called Savortech, where we do architectures and build microservice architectures for corporations worldwide and government organizations. So this is my direct area that I'm always working on day to day. I'm also staff for 3 cats. So whenever I'm developing them online or on IRC and I'm talking to people, you'll see halfway through an IRC conversation how you build up an application, a bunch of weird text. That's one of my cats walking across the keyboard. So let's talk a little bit about microservices. Essentially, it's just an architectural style. I like to break up what we call a monolithic application into many smaller pieces that become easier to use. The challenge here becomes composing them and being able to delineate what will become a smaller part of your overall application. So on the screen, you can see a little bit of a diagram saying when we build something that's monolithic, we're talking about that large binary that has everything from the front end to the back end handling of your application, data manipulation, marshalling, anything you need to do is in one big black box. And you deploy that, and we stand them up and run them. And we do that almost at every company you'll find or any organization. When we start talking about microservices, what we're really looking at is taking that large black box, splitting it up into a lot of smaller applications that help each other. One of the easier ways to give an example of this is when you're using a Unix-like operating system and you have your command line and you have lots of little applications that you pipe together to be able to get larger behavior. That's what we're talking about. The other side of this is that we make everything a little bit smaller so that way it's easier for you to envision what's its use case, is it working, can we test this thing in isolation, and be able to mix and match these different little programs together to get the overall behavior we want. Conceptually, having the smaller services means that this becomes all easier then to develop, test, and maintain. Reality, however, is that things got to change over time because your overall design and your goals and your set of features are going to change. You will have to do bug fixes. Your customers are going to come back saying, we need a new feature. That means you're going to have to take your current set or collection of microservices and change it to a new collection of microservices. So you're going to need some help to be able to do that. You need some organization and strategies to be able to maintain everything together as you're going from a single large object to many, many smaller pieces. So to be able to be empowered to do this, you need to have your choice of tools, frameworks, containers. Everything needs to be adaptable. Everything needs to be able to be resilient to changes and be able to change of scope for what you want to have built and deployed. So from my years of experience in the field, what I've found is there's 5 main areas that becomes the challenges that architects face when they want to move to using microservices and getting their developers to pick it up and their organizations to embrace this kind of architectural style. One area is complexity. If you're working with Java and you're making a very large application, one of the things you'll find is you're going to have not just a couple of jars, you'll have hundreds of jars, potentially thousands of jars, comprising of hundreds or thousands of classes. If you're familiar with Java, you'll end up with a class loader, then you have to work with something called jar hell, where you try to get everything together into a class loader, and things are just getting into the wrong order, so it won't boot up, or it'll be running for so long and then get a class not found. Even though you know you have it provided, it's just hitting the wrong name because of a conflict. So there's a lot of complexity with just dealing with very large code bases that you will get. In microservices, this can get larger because now you're having many, many services, and because they're independently being developed, you may not realize who's using which class, what package names are happening. So you have to be very well aware of the complexities occurring. You need management, a way to be able to work with subsets of these jars. So before, when you'd have a monolithic application with, say, 100 jars, you would start your application and it will just start up and you'd have a huge process running. With microservices, you may have a jar per service. So you'll end up having like 100 services that are all working together to be able to perform the same operation. You need to have the correct set of management tools to be able to handle deploying, upgrading, and testing these various services together. From add-on to the tooling side, you'll need interfaces and consoles, the ability to look into your logging, to take a look at the health of your overall application, all of these kind of things when you're going to a microservice architecture. For testing, you need to go beyond just simple JUnit. JUnit is great for when you want to take a particular object and test all of its signatures, test all of its operations. What we really need to test in a microservice environment is what happens when you take various versions and vendors who make different services that may be compatible, say like a JMS provider, one from ActiveMQ, one from Artemis, one from Mule, depending on who's providing that particular implementation, or different loggers. You're putting all this together, and you need to be able to test combinations and the ability to bring into your container, and does it actually start up and operate well together. And finally, you need to be able to discuss standards with your organization. How are you going to do your quality assurance? What the architectural consistency of your application will be. Will everything be RESTful services? Will you have SOAP interfaces? Are you going to use JMS to asynchronously talk from one service to another? There's a lot of different parts of that you need to talk about with your team to be able to get things consistently working. That being said, when you're using something like Karaf, will make it a little bit easier for you to make a wider selection of choices. So with no further ado, I'd like to present Apache Karaf. Apache Karaf is kind of just a play on the word carafe, or a decanter. When we were first envisioning this project, we were looking for a good analogy for what we wanted to do. If you have a ball of wine, it's not unfamiliar for you to open a ball of wine, pour it into a decanter, and let it breathe before you consume it. The idea we had was that we want to be able to take our applications, pour it into our container, or so install or deploy into our container, allow them to breathe, and have the container take care of everything to make it a little easier to digest. What Karaf is actually composed of is a large ecosystem of OSGI or modular microservice-ready libraries for Java. So when I'm talking about having these being OSGI-ready or microservice-ready libraries and jars, these are various projects that will write either IOC containers such as Spring, Blueprint, declarative services, Felix or Equinox OSGI cores. These are implementations of a Java framework that allows you to do a component or microservice-based build and deploy of applications. So that would mean that you would take your JVM and you have the ability now to install applications directly to the JVM instead of just saying, start up a JVM with my applications and everything's going to run from main. This allows you to have many start and stop points within your JVM. So as an overall framework, what we're building then is a JVM with an OSGI core with a collection of services to make it easier to use a modular microservice-based application. So what this will provide you is a logging system that will allow you to homogenize all of your different loggers. So you can have SLA for Jeff, or SLF for J, you can have log for J, and various different loggers. You'll get one consistent logging config file that can populate all those different logging subsystems. You'll get a simplified ability to set up, say, a web server. It could be Jetty or Netty, but you'll have one configuration file that can spread that out. You have a full set of custom commands. One of the, and I'll show during our demo, one of the really neat features of Karaf is that it gives you a command line directly to your JVM to allow you to directly manipulate what's happening at runtime. It'll also provide to us additional nice things, such as a deployer and provisioning mechanism. What I mean by this is that we have the ability to start treating your JVM now like a full computer. It's already a virtual machine. Let's treat it more like an operating system that we can install running Java applications, update them, and perform other actions. So when you start thinking of microservices, now we're going to start installing more of your applications you've been developing, put them together, mix and match, and see which versions work with each other. So it's a really neat application. For provisioning, what we're talking about is the capacity to go out and say, I need these different libraries, these different specs, these different applications and configurations. Go out to some repository or to my local repository, some file, some web server, grab them, bring them into my container, and install them for me. So it's starting to take away from the DevOps or from the sysadmin the job of, okay, I got to stand up an application. What do I need? Am I missing anything? And having a developer write a wiki page to tell me. We're getting into the ability for it to go out and grab these things and install what the developer actually intended to be with your application to start and run it. So, to talking about empowerment, what we mean by this is that Karaf is going to bring organization and structure to your microservice world. Karaf is going to provide you with the tools and the mechanisms you need to be able to manage the complexity and all of the various essential functions your teams are going to have to perform, from testing to automating to provisioning to deployment. All of this will be done in a Karaf way. So all of this magic starts with our command line. When you start up a Karaf distribution, the first thing you're going to see is a little splash page that says Karaf, what our version is, and then gives you a Karaf prompt. That Karaf prompt is going to be very familiar to you if you're using Linux or a Unix system. Back in the day, a lot of the original developers were working on Windows machines, and we desperately wanted to have a Linux prompt. So a lot of the Linux philosophy of having pipe and grep and the ability to add scripting to your shell was put into this. So it allowed us then to start up a JVM and have now a much more visceral ability to get into your processes that are running and start seeing what's happening. When I run the live demo, what you'll see is that you put in an application to Karaf, it'll get essentially a process ID. We call them a bundle ID, but it's essentially a PID. So at this stage now, you start installing microservices like applications onto your desktop. You'll get a process ID in your JVM, and you're starting to be able to mix and match things, look at their versions, and you're starting to put a whole lot of things together running side by side instead of just one JVM, and you don't really know what's going on inside of it. Further to this, when we start talking about being able to install things, we follow something called the OSGI specification. We use it at the very lowest level or finest granularity of a bundle or a jar, but we also bring this up to a higher level we call a feature. Essentially, what we're trying to show you is that we can install a collection of jars, configurations, applications together, and compose a larger application out of these microservices. Following from this, what you can see will happen is that when you can start composing all of these installable, updatable, restartable, reconfigurable microservices or applications, is that you can compose and reuse all of your software. So you start building up jars and libraries to perform, say, a RESTful service that takes in an order. You can then reuse that portion and then start adding in other backends to it just through configuration or adding in the correct next set in your pipeline of little applications. The provisioning mechanisms inside allow us to connect to a technology called Maven. If anyone here familiar with Maven or Gradle? Okay, so if everyone's familiar with those. For those who are not, essentially what Maven will do for you, it allows you to define all of your dependencies you need for providing a build. So if you want to build your source code, it'll go out to a set of repositories, download your artifacts, your jar files, put them on your class path, allow you to compile your code against it, and then produce your jar. Inside of Karaf, we have the same mechanism to allow your jars, when you install your applications, to go out to various Maven repositories, get all of the dependencies your app require, download, install that into your container, and start running. This simplifies things because now you're not in a situation where you've developed your application and you have to provide that additional set of wikis or what do I need to run my app. Your app, by being built for the system, will automatically go out and grab what it requires. You can also go to a local file server or to a web server to be able to grab your configurations or jars. So there's a couple of neat little mechanisms under the hood to let things work. We provide a deployer service. So what this will give you is a hot installation capability. What I mean by hot installation is that I can take a jar file, a WAR file, a WAB, you name it, throw it into an installation folder, and Karaf will then take care of all of the mechanisms to get its dependencies, its configurations, stand up all the services, wire it all together, and then start all of them so your services are starting to work. This is a great mechanism because what this is actually allowing you to do now is compose your microservices into your full application. So you're going from doing one little piece, one little piece, one little piece. Now you're doing large pieces and getting them all together and making your full picture. A little bit onto this is that you'll see we can create something called a custom command. Application developers in a lot of different libraries have framework groups, so Camel, ActiveMQ, and other organizations. What they have done is they've put together customized Karaf commands that allow you to dial into that particular framework or that application and manipulate it at runtime. So you can conceivably write your application, create a couple of mbeans or a couple of hooks into your app, and then from a command line of your running JVM, be able to hook in and say, what is this value, variable value? How many threads am I running? What's the status of my application? You can dial in. One of the neat little side items we put inside of Karaf is an SSH server. So you now have a JVM you can SSH into from your phone and then find out what is the status of my running app, which is kind of a neat little hack you can do directly just from the framework. So then the biggest challenge we get then is how do we start growing these applications? When I'm saying grow the applications, I'm not talking about horizontal scaling or the vertical scaling. I'm talking about the complexity of working with microservices, where you're having many services together to perform a larger goal. So in the small scale, when you only want to build something really small and it becomes kind of obvious, you've got 4 or 5 parts that if you mix and match them together, you're going to get something close to what you want. Generally, all of us are capable of handling that. You'll just install jar 1, 2, and 3, and it all comes together. And when they're running together, your service is born, your entire application is running. The real problem happens is when things grow and you start having hundreds of jars configurations and other sets of jars configurations as their dependencies. This is the problem that Karaf seeks to help solve for microservice developers. Our solution was something called a features descriptor file. What a features descriptor file would do for you is that it allows you to define all of the different dependencies and the bundles or jars that you've created and configurations you've created to build your full applications. Once a feature file has been defined, it creates what we call our features descriptor. You can think of that descriptor as being like a catalog. So this feature file will contain a set of targets that will define parts of your application. When we do our demo, I'm going to show you one where we'll have a front end and a back end, a domain part of a project. So you'd be able to target which part of your application you want to work with. The real neat part here is that then you can also reference other catalogs or other feature descriptors that are published by other projects. So you can say Camel, which makes EIPs, that's enterprise integration patterns, or ActiveMQ makes a JMS broker. You can say, give me your catalog, and I'd like to be able to get your broker. I want to get your RESTful service. I want to be able to get your web server. By putting their feature catalog in your features descriptor file, you now have access to that. So you can start putting dependencies into your larger application, and it really allows you to then start looking for microservices as being a couple of little apps to being large constellations of apps that now you can start defining and be able to manipulate as one. Finally, the next part that Karaf starts providing for you is something called, comes from the PAX exam project, or PAX from Ops4j, but it's been heavily modified for Karaf. We give you a full stack testing harness. What I mean by full stack testing harness is that we have the capability to take a full Karaf distribution, give it a basic configuration, and say what set of services you want from default from when you start the container, list all of your features and other features provided from other providers in that distribution, start it, install your apps, and now your app will be going from clean installation of a JVM, installation of Karaf, installation of their services, other third-party apps, and then your application. And you can boot it all the way up to a full runtime to say, okay, has anything gone bang yet? Your next step is then add your functional test of let's send in a request and see if we get a proper processing out the back end. We do this during our build time, so you're able to say essentially that you've done a full smoke test and build, that you can take a full clean container and build it all the way up to fully stand up your stack with your application, throw data through, and get it out the back end, which is incredibly useful for a developer, especially in smaller shops when you don't have a full set of QA teams that you can just hand off to take it and build up from scratch. It also helps you from the point of view that since you're writing full unit tests that describe the entirety of your stack from a clean JVM to a fully running solution, you've documented at that stage everything you need to build your apps. So I'd like to talk about a pair of user case stories that are some of the larger deployments that I've seen of Apache Karaf. So one area that in the last year and a half has really exploded in heavy deployment comes from the worlds of software-defined networking and open network function virtualization. There's 2 projects involved with this, OPNF and Open Daylight, also Honest. Essentially what they've done is that they've come through with a white box way of being able to rebuild the internal switching of your TCP/IP stack. This is what the telcos are going to be using to be able to provide us all with IPs. So very heavy, high-level use case. Very low down, obviously, in the networking stack, but when you're talking about the number of users and the kind of applications required to build this, it's quite substantial. So Open Daylight came to certain members of the Karaf community and said, we have our application, we've built it. Essentially, it was a monolith at the time. It was a little over 1,500 jars, which would represent thousands of classes that have been written. That implement everything from DNS to how IP networks works, how a switch works, how port routing works, all of those really neat things we all need to have our back-end switches operate. We took that general monolithic application design and then broke it up into Karaf features. So we had areas for DNS, areas for security, areas for the web console, everything that you would need to be able to make your switch work. And then re-architecting that project made it much easier to operate. The initial download of that used to take about 4 gigs of RAM to be able to boot it up and actually stand up all of the objects and services that was required to get to run. Once we made switch to Open Daylight, we managed to get it down to a couple hundred megabytes because we were able to pick and choose which services we wanted to run. We didn't have to stand up the entire world. We could just pick and choose which microservices we wanted to run at any given time and be able to offload and reload what parts we would actually need. So from the Karaf point of view, it means that as we start to disperse these now into various telecos, we're actually able to start seeing Karaf getting heavily used throughout the world now. Another user story that I've included in here with a link to a particular presentation on it. The country of Ecuador uses a Karaf-powered design to be able to provide all of their social services. So if you were to watch that in full presentation, what we'll go through is they talk about using Service Mix. Service Mix is another distribution of Karaf. It's just a rebranding of what we build. That allowed them to put between their existing set of solutions and servers, a set of adapters, and talk to a front end of web services, so RESTful services and SOAP services. Putting Karaf in between, they can then make all these little applications that can talk to databases, to brokers, to anything else they needed to do. They could just create all these little microservices to be able to communicate from traditional modern web design to these older back-end systems that they had in place. And then they put it basically all together and put it open source. So you can go and download and take a look and see how they did this overall architecture. I point this one out only in that with Service Mix, it's basically Karaf with Camel, ActiveMQ, CXF, and a couple of little other libs added inside of it. So they took a couple of microservices, put it inside of our container, boot it up, and then they're able to wire this all together to allow their modern web services to be fronting older back-end servers that they have already standing up. So it's a really neat demonstration of how this is being used in the wild. So the part I really wanted to get you guys to is I wanted to build a small microservice-based application and deploy it onto Karaf so you kind of get the full flavor of what all of this does when we bring it together. So I built a project and I put it onto my GitHub. So I realize right now it'd be on our Wi-Fi. We probably can't all download it now. So I'm just going to show you the source code and then fire up an editor and let you guys see this all run together. So when you read the slides later, just follow these instructions and it'll show you what you need for your Java 8, your Maven version, setting your path, downloading a Karaf kit, and then a little app for Chrome called Postman will allow us to send a message into our system. So the application I'm going to build here is just going to take Karaf and we're going to deploy into it 4 components. The first component is going to be a front end. The front end is essentially a little service that's going to be able to accept a JSON message being sent into the JVM. I'm going to have a back end piece that's going to be able to take this message, read what's inside of it, and process it and send information that's been given to it to various locations. Between the front end and the back end, I have a common set of libraries that I just call a domain. So it's just going to be the domain area, the business logic. And I have a 4th service that's called JMS. That one is just an ActiveMQ broker. It allows us to send Java messaging. Traditionally, with web services, people say that it uses like a SOAP API or a HTTP API for one service to talk to another. In this case, I'm using ActiveMQ. The rationale for that is that it allows me to do asynchronous communication, and it would allow me to separate and split out an application to be able to scale it horizontally if I wanted to. So looking very closely, I'm showing this as an EIP. Don't worry, the EIP portion of this isn't so important to microservices. It's just letting you know what the actual application is going to do. It'll take in this post of JSON, it'll go and do a content-based routing based on what's inside of an order form and send it off to various manufacturers. So let's look at the first application. I'm going to stand up a RESTful service in Karaf and then be able to send it off to a response processor. It's going to tell whoever went on the website, yeah, we've accepted your order. And during that, I'm just tapping that off and sending it down to a JMS service. The code I'm writing here, and I'm just showing you this as some configuration file, so don't worry too much about the actual code that's on the screen. But if you download the code from GitHub, you can go through and see how this is all implemented. Essentially what I'm doing here is that I have a configuration to stand up a RESTful web service that's going to listen on port 9090 and look for a JSON post to come in. And then I'm going to configure up a connection to an ActiveMQ broker, and then wire it all together with something called CAML. All CAML that you need to know about right now is as a little wiring language that allows you to say, I want to take data from point A and send it to point B, and gives you some various options in that route. So what this little application will do when it's built together as a single microservice is going to be a little application that when I put it down, it's going to say, listen to a port, it's going to be JSON, give a response back that I got your request, and then send off a JMS message to some queue. I build another microservice that's going to encapsulate all this domain logic area. So domain logic for here is going to be what is an order, what is a response, what is an item. So if I get an order for 5 iPads and 2 Surface Pad Pros, there would be so many orders for Apple, so many orders for Microsoft. It's just the concept, the objects. And then the third microservice that I have in place is just a set of routes that's going to be able to take this order, look at what the content is, and be able to split it to the various manufacturers. So it's kind of a simple EIP for that. And then once a manufacturer gets an order, be able to marshal it to a format that they can actually use. So the source code you'll see there is basically just going to set up ActiveMQ connections to be able to produce and consume JMS. And then the actual CAML route that will say, pick up an order, read it, split it by the different items inside of it, and send it to wherever it needs to go. And then the final couple of routes are just give me something from ABC, marshal it, send me an order form for here, XYZ, marshal it, give it to an order form for that company. So what's interesting from that is that we have 3 little applications put together. One that's providing a front-end service, one that's doing back-end logic, a common set of domain business logic to describing objects, and a fourth one that's a little bit hidden is an ActiveMQ service. So we have 4 things that we're going to want to install and be able to mix together to get to a full application. Where Karaf will step into this now fully is when we start writing something called feature file. The feature file I have on the screen, there's 2 important parts here. The top of the screen is showing you repositories. Think of that as being your catalogs. I know for this application that I'm going to need CAML, CXF, and ActiveMQ. So I'm going to reference that I want to get their catalogs. So now I'm going to know anything that those projects post about being able to install microservices from them. I'll have those available to me now in Karaf. Then for our own application on the BOM terminal, I'm listing off, I know what my dependencies are for my application. I know I need to have CAML blueprint, I need CXF, I need AMQ, etc. And then I have my own application, which are 3 jars. The front end, the back end, and domain. I could have split that out to being a front end target and a back end target, but just for simplicity, I've got it as a single target. And then an all parts, so the dependencies from plus my application target. What these targets will be installable commands. So I'll be able to say, I want to install just my dependencies. Karaf will go out and just grab all the dependencies by these catalogs, download them, and install them, and stand them up in a JVM. For my application code, I'll get those out of my M2 repo, download them, put them into the Karaf, start them all up, and wire it together. So it's starting to automate being able to get all these microservices to come together and be able to put into a constellation that can perform a full application. To further this, the next part we need to do with Karaf is that we want to test this. So it's kind of hard to read the code here, but sufficient to say what this is doing is it's creating a unit test for the full stack. The beginning of this is a preamble that says, give me a Karaf distribution, so in this case 4.02. Give it a basic set of services and configure a couple of ports so it doesn't conflict with my locally running SSH or RMI ports. Then, most critically, create a unit test where I'm going to say, I want to install these particular feature targets. I want to install my dependencies, and I want to install my application bundles and put them together and start it inside of Karaf. When that occurs, then you'll have a full Karaf with all of your application, all of the dependencies, everything standing up, everything running at once. The next step for you then would be to add functional test cases to say, with everything installed, now post a JSON message to this port and go to this particular file folder that we will be looking for the result and say, do I get what I expect? Then you can say you've passed or failed your actual smoke test. This is a really great capability because now you have the ability to take a full JVM, install everything that you want, all your dependencies, all your configurations, stand it up and see, do you have a full application that runs? So just to be able to show what some of those screens will look like before I get to the full live demo, I use Maven as a build tool that will go off and get all my dependencies. It'll build all of my applications. It'll get my dependencies. It will build a feature file for me, and it will also go and run that I test. When I do the live demo, I'll scroll back so you can see where Karaf actually boots up, and you can see the installation of everything, verifying that the application that's been built can actually execute at runtime. And then when we start up Karaf itself, we'll issue two commands. One is telling it about the catalog we built for our application, and then the next command is going to be installing the actual targets that we defined in our feature file. Then once we do that, I'm going to fire up Postman and set it to be able to use a JSON body, send in a particular formatted object. In this case, I'm going to send in a customer is ordering parts from ABC and XYZ. And then I'll get a response, so I'll know that the service was able to talk to the front end, and then I'll go down to the file system to see that things got split off and given to a backend file. So let me just bring up a command line for you. Okay, so is this visible to everyone behind? So this is the source code is available from my GitHub repo. I'm going to just do an offline build right now because I'm not on the Wi-Fi. So what this is going to do right now is it's going to go out and it's going to download all of the dependencies that are required for building my application and then build up microservice by microservice each jar file. And then after that, it's been set up to build my features file, which is going to define what my entire constellation looks like, and then run a unit test that's going to stand up a Karaf, install everything from the dependencies to my applications, boot it up, and see that it actually runs. So with the build being successful, I'm just going to scroll back up so we can see where the unit test had ran. Here we go. So we actually can see in the logging from this that Karaf had started up, and then all of these outputs, you can see it as it's going out and installing dependencies such as ActiveMQ, Camel, CXF. Eventually, you'll get to my actual application bundles has been installed and stood up. So we're able to say that at the end of this unit test, the full stack is in operation, which then would give me the confidence to be able to go to a running Karaf, which I'll boot up here. This is the one. Okay, so start a full Karaf, and just to show you that it's an empty container list. Karaf has its own set of commands that allow you to start seeing what's going on inside of your container, so inside the JVM, what's happening. So right now, I've just started up a basic JVM. I have no applications installed. I'm going to install to it the XML file we just created. So that's the one I was showing you on the board. And what this is going to provide me with is, and I'm going to grep this out to -I FSTO. This is going to show me what's inside the catalog I just described. So inside of that, I have a set of dependencies. I have my list of applications, or I can say I want to install all of it at once. Just for completeness, I'm just going to show you installing only my dependencies. Install FSTO. Oops. Install tab complete FS. Where are you? Deps. So right now, Karaf is going out. It's taken that feature file and said, here's all these different catalogs, and that lists off a bunch of dependencies I'm going to need in my JVM. So it's gone off ahead now and picked up from my Maven repo copies of all of those jars, installed them, configured them, and set them all up so they're now all executing and running as small microservices. On the side here, we can see an ID. Think of those as being your process IDs. So I have the ability to go to any one of those individually, start, stop them, uninstall them, update them. I now have full capacity to control what's going on in my JVM at runtime right now. And if I want to, I can go in now and install the rest of it, so the actual FSTO application. And I'll just type list so you can see that it's actually installed a set of extra bundles. So these are the back end, front end, the common domain. All of those little extra jars now have been installed, stood up, and are now executing. So if I look at my log file, I can see that the Camel router has actually stood up, it's running, it's available, it's listening. There's a CXF server that's been set up, it's now running. All these little microsystems have been mixed and matched, composed to run a full application. So if I go on to Postman, and I'll bring that up onto the screen here now. And I'm going to go here. So in Postman, all I'm doing is I'm just saying I'm going to create a message, and it's going to be JSON. And then I pass into it a JSON formatted object. So in this case, I'm going to be customer information, a set of widgets from ABC, and a set of widgets from XYZ. I'm going to send it in. And we'll be able to see the response came back from the running application. If we look inside of the display, we can see a bunch of messages actually ran through. I'm going to run a command here called camel context list, and then camel, just as a demonstration, route list. Okay, so those camel commands, that's actually not part of Karaf. That comes from the camel framework itself. Those are custom commands that allow a camel developer to go in and say, what context have I created? What routes have I created? Those are those little applications that I was showing from XML. Using a couple of custom commands, I can go in and get a little bit more information. So I'm going to go to route 1 just to say message came in. Writing up commands like this allows us to create our own applications and get in and say what's actually happened within my application. If I create little counters saying like messages in, what my runtime was, how long did it take for a particular process to be done, is really neat that way that you can create these kind of monitoring tools. If we were to dive down just to the folder and see what was created, I'm just going to cat out target, manufacturers ABC, and it's JSON. Oops, cat, that's what I want. Oops. Oh, just what's the number on this one? Is that 2? Sorry. Trying to see now which one is it actually. There we go. I had ran this twice. It'll show the actual file that had been marshaled and created from putting in the output. So from all of this, we're able to assemble 4 different microservices, or at least from our point of view as a developer, we wanted to have a JMS broker. We wanted to have a front end that could take in a post message. We wanted a back end that can read an order coming in and split it off and marshal it for various back end providers or our suppliers. And then be able to put it all together and treat it as one big application we can just point at and say, install all of this, give me the full world. So from that point of view, that is what Karaf provides us as developers. It's a framework that basically gives us the capacity to start working with microservices, be able to control what happens from one application to another, how to update them, how to be able to provision them, how to be able to deploy large collection of them at one time and operate upon a collection of microservices all at once. I would like to thank you for your time. It was my pleasure to be able to talk to you guys about microservices and Apache Karaf. And if you have any other questions, you can talk to me after the talk. Thank you.